We're going to take a look at some basic shapes and shifting them by moving around their important landmark points. And first I'm going to start with the parabola. And so for what I call the basic parabola, y is equal to x squared, this has its center at the origin. And there are also points at 1, 1 and also 2, 4. So we'll just go ahead and draw this parabola. And so this is the basic shape that we are starting with. And we can shift this parabola in both the x and the y direction. From this equation, y is equal to parentheses x plus 3 squared plus 1. The plus 1 would cause this to shift upward, and the plus 3 connected to the x would cause it to shift to the left. And we can see this more clearly if we subtract 1 from both sides and put y minus 1 in parentheses is equal to x plus 3, also in parentheses and then squared. And when we look at the offsets, or the things that are subtracted from our x and our y coordinates, we are subtracting a negative 3, that's what gives us the positive 3. And from the y, we are subtracting a positive 1. So what we have essentially done is relocated our vertex at this new point, negative 3, positive 1. And what we can do from here is redraw the parabola, but going through the new vertex. So again, we have the same shape, but it's shifted up by 1 unit, so we can see that this is moved up by 1, and it's shifted to the left by 3 units. We can do something similar with the horizontal or the sideways parabola. So the equation for this is x is equal to y squared. This time it's the y coordinates that's squared, and that's why it faces in the horizontal direction, and it's a positive in front of the y squared, so it faces to the right rather than going to the left. And just like before, we can take the coordinates and shift them by subtracting off the numbers that correspond to the vertex. And let's correct this formula. This should be x plus 3 with no square here, and this should be equal to y minus 1 with a square on the y expression corresponding to the original square on the y. So just as before, we're going to relocate the vertex according to the numbers that are subtracted from the original x and y coordinates. So here we've got x plus 3. That means that we have subtracted off a negative 3 in the x direction, and y minus 1 means we subtracted off a positive 1. So again, we have our vertex at negative 3, positive 1, but this time we will transfer the sideways parabola to have its vertex in this place. So we end up with the shifted parabola, again same shape, but just with a new vertex at negative 3, 1. Next, let's take a look at the equation of a circle, and these also can be shifted from the origin. This equation, x squared plus y squared is equal to r squared, describes a circle with radius r, and in this case I've given the example where the radius is equal to 3 by putting a 9 in this position. And if we were to plug in various points, for example, x is equal to 3 and y is equal to 0, we would see that 3 squared plus 0 is equal to 9. Similarly, the point 0, 3. When we square the 0, we get 0. 3 squared is 9. That's also a point on the circle. And we can have points in the negative direction. Negative 3, whole thing squared, is going to still give us positive 9 plus 0, and this gives a true equation. If we look more generically at the equation x squared plus y squared is equal to r squared, we can solve for r, the radius, as the square root of these numbers. And this is similar to the distance formula. For example, if we were to try to find the distance between 2 points, the origin 0, 0, and the point with coordinates x and y, we would subtract off the x coordinates, x minus 0, square that, y minus 0, square that, and we would get the same formula that we see here. And what that tells us is this points on a circle have a certain fixed distance, in this case from the origin. And that fixed distance in this case is 3 units. So we can go 3 units in every direction, certainly along the axes, but we can also go 3 diagonal units, and that'll give us points that look something like this. and then from that we can draw the circle. And so again, we can see that every point on this circle is a certain fixed distance or radius, that is 3 units away from the center point of the origin. Next, we can take this circle and we can shift it to a new center, h and k, in the generic formula. But for our specific case, if I wanted to shift it by subtracting off different coordinates, I could have an equation like this: x plus 3 whole thing squared plus y minus 1 whole thing squared equals 9. And we've subtracted off a negative 3, that's why we get a plus here, and we've also subtracted off a 1. And so our new center is at the point negative 3, 1. And so we'll put our center here, but the radius is still equal to 3, so I will go 3 units in every direction. 3 units to the right, 3 units up, 3 units to the left, and then 3 units down. And then, rather than drawing a diamond, I will draw curved arcs between each of these points. And again, each of the points that's on this circle that's drawn is equidistant, that is 3 units away from this new center. And so, more generally, we can give the equation for a circle which has a center not at the origin, but a center at any point, as being x minus h parentheses squared plus y minus k, also parentheses squared, is equal to r squared. And whenever we have our circle equation packaged up in this format, we can easily pick off the coordinates h and k, use those to plot the center, and then just draw the circle from the given radius, which is the square root of whatever number is over on the right-hand side.